about line CD, what do I need to do?
Take the magnitude of the I component times the moment in the I.
Okay, so I do MC dot ECD, right? So that comes out to be negative 180 times negative 6,400 plus 36 times 0 minus 150 times 0.7680. So remember, there are two different ways to find the unit vectors. Sorry, there's two different ways to find the dot product. One is by finding the magnitude of each of the vectors and multiplying it by the cosine of the angle between. And I think that's what you were alluding to. But we don't know what that angle is. We don't know the angle between those because this force, this moment at point C is sticking out here, remember? We determined that. But I do know the x, y, and j component of the moment, and I do know the x, y, and j component of the unit vector, so I multiply the x's together, the y's together, and the z's together. Good? What did you say, Helen?
Then without the cosine.
We don't need the cosine. Remember, there are two different ways. If we go back to our packet, on page 4 of the packet, remember, we knew already, in order to find the dot product of two vectors, we either take the magnitude of both of them and multiply it by the cosine between, or you take the x's and multiply them, take the y's and multiply them, and the z's and multiply them and add them all together. Okay. So since I know the x, y, and z components of the one vector, and I know the x, y, and z components of the other vector, I'm not going to involve the angle because I don't have it. So I'm going to just do this. And in the end, what do you get? Calculate it. Sorry?
107.5.
7 point.
107.5.
I got 0.
Very good. Oh, 150.
Santiago, we're up to you. There are two instances that a force could create a zero moment about a line. What are those two instances? Here we have a force, and we see the direction of force AB. That force is creating a zero moment about line CD. What's the relationship? There are two different relationships that line AB and CD can have in order for it to create no moment. What would be one? Think back to the 3D right-hand rule. If I'm trying to find a moment in this direction, if I have a force, if they're parallel, if the force and the line in question are parallel, the force does not create a moment about the line. Everybody got that, right? The only way a force could create a moment about a line is if it's off the line, and then it can spin. But if a force is parallel to the line, the only thing that can happen to that line is a translational force, not a rotation. Joe, what's another situation where a force would create a zero moment about a line?
If it's pushing perpendicularly to the...
Not even perpendicular, if it intersects, right? Because we already know that if we have a force and it goes through a point, it can't create a moment on that point, right? There's no lever arm. So if I have a force of FB, and it intersects that line, then it can't create a moment about that line. So looking at this in 3D, look at line AB, and then look at line CD. David, does it appear that AB and CD are parallel, or do you think they intersect?
Neither. Or, oh yeah, they're gonna intersect.
It has to be one or the other, right? Because we calculated a moment. That force creates a zero moment about CD. It's got to either be parallel or intersect. And which one is it?
Intersect.
It intersects. And I did it mathematically. I took the equation of both those lines and found if there was a point of intersection, and there is.